All right. So the name of this presentation is Trustno1, Protecting Your Data in a Zero Trust World. My name is David Branscome. I'm a Senior Security Architect at Microsoft. This is me. I'm based out of Raleigh, North Carolina. I've been with Microsoft going into my 13th year and 20 years in the industry. Multiple jobs in Microsoft Consulting Services, Premier, and now I work with Microsoft partners, a bunch of certifications, and I would love to be at the beach now if this pandemic would ease up a little bit. But in any case, here's where I show you how tragically old I actually am. So how many of you remember 1998? What is it you remember about 1998? Wes Bailey's raising his hand. Anybody remember these two? That doesn't look like Hillary Clinton. I wonder who that was. I remember having one of these, Sony Discman, Walkman, depending on what flavor you got. Some of you might remember this game where Michael Jordan was playing with the flu and won in the last couple seconds. And a little company named Google got started in 1998. And one of the other things that happened, this is one of the things I remember from 1998. So at the time I was working in the stock exchange in San Francisco when there was a stock exchange in San Francisco, and I was in the networking department, and Novell was ruling the day at the time. We managed a group-wide system, NDS, and it was rock solid. We loved it. It was fantastic. And this little upstart Windows NT and Windows 2000, we were told to start learning it and start learning what Active Directory was and how it could be used in the network. So started learning that. I was actually in charge of one of the security departments there at the stock exchange. And at the time, I had what I thought was a pretty unguessable password, Trustno1. Now, what's funny about this is that on July 16th, 1998, CERT reported there was an incident where an attacker had found 186,000 encrypted passwords. And at the time that the attacker was discovered, 47,000 of those passwords had already been cracked. And sometimes I wonder, looking back now, if one of my passwords had actually been in that cache. And the reason I wonder that is because if we fast forward 15 years to the year 2013, by this point, I was working at Microsoft, and my security practices, I think, were moderately better than they were back in 2001, or 1998, actually, is when that originally started. But I had kind of gotten into security in a much bigger way, and I liked nosing around on the dark web and taking a look at different things. And one of the things that I like to look for is password caches. And there was one on Pastebin, and I was looking through it. And as you can see here, there was my password at number 9 on the password guessing text file that was there on Pastebin. So that was a little unnerving. I wasn't real happy about that, but my password was slightly better than let me in. And a little bit worse than Dragon, and a little bit better than 1, 2, 3, 4, 5, 6, 7. So that was a little bit of an eye opener. Some of you may be familiar with a website called Information is Beautiful, and they do word clouds. And this is a word cloud that they did for common passwords. And if you notice, there's my password again, Trustno1. There's some other ones in there that are pretty obvious. You see NCC 1701. That's a reference, obviously, to Star Trek, Rush 2112, and OU 812, or Rush and Van Halen records. And then a whole bunch of other ones, Jordan 23, Bond 007, whole bunch of just common names and phrases that people like. But this was, you know, again, the higher up you are and the bigger you are means that the more targeted that password was. So Trustno1 was no longer a password that I could reliably use in any sense. Let's move forward a couple more years to 2019. So we're looking back on 2019 now. Microsoft did some research, and one of the things that they found is that by 2021, 25% of the world's personal data will be compromised and housed in a data lake that can be analyzed and utilized by consortiums of threat actors. So things like passwords, social security numbers, credit card numbers, all this kind of stuff. About 25% of everybody in the world's personal data will be available in this massive data repository that will be shared by these threat actors. We've seen 750% growth in the number of ransomware families just in 2016. Now, if you think about this, 2016 predates the Petya Not Petya ransomware attack, the SamSam attack, some of the more prominent ones that have come out in the last 2 or 3 years. And we saw 750% growth back then. So we can reliably assume that the growth has been just about comparable or even faster in the years since 2016. And the third thing is that by 2022, a third of successful attacks experienced by enterprises will be on their shadow IT resources. Now, when we talk about shadow IT resources, what we're talking about are services or applications or cloud applications that departments within an organization may acquire for their own use without the knowledge of central IT. And the reason that's a threat is because that if central IT isn't securing them, then it's very likely that nobody is securing them. So what these things all put together lead us to is my password, Trustno1. We really can't trust anybody to protect our personal data. We have to be able to trust our own machines. We have to be able to trust the reliability and safety of our cloud app resources. So let's take a look at what we can do to fix this problem. Now, this is kind of a metaphor for what security used to look like, right? You had a firewall, people would try to get in, there was a door, it was mostly closed. If traffic was right, you could get right in, no problem. But that's no longer the way things work. We now have this concept of zero trust, and I recognize that Microsoft isn't the one that came up with the phrase zero trust. We're certainly not the only ones that have a methodology around zero trust. The way that Microsoft views implementing zero trust is outlined in this URL at the bottom, aka.ms/zero-trust. And so what we're going to try to do over the next couple of minutes and with some demos is show what zero trust is, the 3 principles behind how Microsoft looks at zero trust, and if you're running a Microsoft network, what are some ways that you can implement zero trust on that network as well. So first of all, what does zero trust mean? The principle behind zero trust from a Microsoft perspective is that we don't trust anybody to access data unless they have explicitly proven themselves to be who they say they are, that they're connecting from a trusted device, and that they have a right to know or a right to that data. So in other words, I've got a user that's logging in on a machine and they're trying to access a particular set of data. So what our zero trust model is going to do is look at things like, what is the workload that they're trying to access? Are they using Exchange? Are they using SharePoint? Are they using Teams? Are they connecting to G Suite? Are they using Salesforce? What is the workload that they're trying to get to? Are they allowed to use that workload at all? And if so, what permissions do they have on that workload? Then we look at the person themselves. In other words, their identity. Is the identity that they're using one that has potentially been compromised? Are they logging in from a location that is considered to be untrustworthy? Are they logging in using a pattern that doesn't match their typical login pattern, a time of day, or a physical location that doesn't look right? What is the device that they're connecting from? If most of the time I log in using my Windows Surface Book, and then all of a sudden they see me trying to log in using a MacBook. That's out of character for me, and it's going to raise the risk factor. It doesn't mean they're necessarily going to block me, but it is going to raise questions about whether I am who I say I am. Now, if all these factors start to raise risks, then we get to the point of saying, okay, let's look at the intelligence around this. What's going on with all these anomalies? Each one individually might not be such a red flag, but if you put all three of them together and you put it together with, what is it they're trying to do? Is David trying to access the HR system, which he never tries to connect to on a normal basis? Is that something that we want to allow? That's the concept behind Zero Trust, is putting all these pieces together and starting to make decisions and forcing users to prove who they say they are and prove that they are reliable. And this is true even within Microsoft. Depending on what workload you're trying to access, you may even be prompted for multi-factor authentication inside Microsoft's corporate network. So it isn't just considered Zero Trust outside the corporate network. It's Zero Trust inside the corporate network. And that's an element of or a factor of the assume breach mentality that Microsoft has. We assume that there has been a breach inside the network and that there is a malicious actor inside the network, and so nobody can be trusted. No network can be trusted implicitly. You still have to prove who you are. Now, a lot of you have seen the attack kill chain, and so I'm going to just build this out real quickly. But what I want to do is kind of walk through some of the steps here and discuss how Microsoft tools can help you to protect your data against different phases of the kill chain. Now, we know that it only takes about 24 to 48 hours for a threat actor to get access to domain admin privileges after a successful phishing attack. And that's usually where we see these types of attacks taking place first, whether it's a URL that drops some sort of malware onto a victim's machine, and then they're able to exploit the machine and get command and control, or if they're able to open attachment, which does the same thing, exploits the machine, or maybe they can steal credentials through a password spray attack, a brute force password attack, whatever it might be. In some way, shape, or form, they get control either to a machine and then credentials, or they can get access to credentials through some other method. Now, we try to cover every single phase of the attack kill chain. So if you have Office 365, or Microsoft 365, it's now called, there is Office ATP, Advanced Threat Protection, for email, which can protect against malicious links in email, malicious attachments. We have different tools that can prevent the compromise of user accounts, use of stolen credentials. I'll show you these tools as we go through the demos. Once a user account has been compromised, then the attacker is typically going to do a couple things. If they've compromised just a standard user account, they're going to try to move laterally on the machines in the network and try to find a machine that gives them credentials that are useful to them, whether it's credentials to some SQL database with HR data or credit card data, or if it gets them to domain admin privileges, they're able to elevate the privileges to the level that they need to get the stuff that they want. And really the important thing to remember here is that getting domain admin is not the end goal, right? The end goal is to get enough privileges to get the data that they want. Domain admin typically does that, but if they just need access to a file that has credit card numbers, that's all the privileges they need. They don't necessarily need domain admin. They just need enough privileges to do what they want to do. So while they're going through this process of compromising accounts, they start looking around and figuring out where the data is that they can most effectively use. And so here's where things like Azure AD Privilege Identity Management, making sure that those privileged accounts are only used for the time period that they're needed. There's no standing privileged account access. In other words, a person doesn't have standing domain admin privileges or standing exchange admin privileges. They request those privileges, are granted those privileges for a period of time, and then those privileges are revoked, so that even if an attacker is able to get on that user's machine, those privileges no longer exist and they can't be utilized. Once they establish domain presence and persistence, things are kind of bad at that point. But one of the things that we often see is that once the attacker gets access to the data that they want, they start exfiltrating it through one form or another. And so we have the tool called Microsoft Cloud App Security that allows you to protect different workloads, even non-Microsoft workloads, from being from the data being exfiltrated to other locations. So let's take a look at the different ways that we secure this. So the third way really is the identity, protecting the identity. So identity is really the core of the zero trust methodology. If you can't protect the identities of the users, then really the game is over before it's even started. And so that's why Microsoft is looking at Azure Active Directory as being the core security element of not just Microsoft products, but of thousands of other applications that can leverage Azure AD for its authentication. And so we build really, really powerful security controls into Azure AD to make sure that those identities are protected to the greatest extent possible. If you're using Azure AD to authenticate to your CRM system, to Salesforce, to Box or Dropbox or Google Suite or Amazon or whatever it is, you have to make sure that that identity is protected very well. The next concept is assume every resource is on the open internet. In other words, this is the assume breach thought process. So again, if we see a user logging into a machine, whether it's a laptop, a mobile device, or a standard desktop, we're looking at intent, right? This is not meant to spell internet. We're looking at their intent. And we derive that intent from this set of scoring criteria. What is their identity? What is the device that they're trying to connect from? What is the location? What's the workload they're trying to get to? And pulling all that data together, we come up with a risk score that helps us to determine whether this person trying to use this device to access this workload is a valid combination. And so we're left with this concept, again, of never trust, always verify. And so that brings us back to trust no one, right? That's what the concept of zero trust means. Now, what I'm going to do here is drop out of the PowerPoint presentation, and we're going to go through several of the tools that Microsoft has available in the M365 suite that you can use to secure your environment. So what I've done here is I've kind of pre-staged some of my tabs just so things are quicker to move about. But once you get into Azure Active Directory, one of the first things that you can do is leverage Identity Secure Score. Now, many of you are probably familiar with Microsoft Secure Score or maybe Office 365 Secure Score. This methodology of scoring is becoming common across most of the workloads in the cloud for Microsoft, and a lot of vendors are also following the same methodology. The idea is that there is a value that you potentially could get to. In this case, it's 203. And then the controls that I have implemented add up to 93. So I'm a little bit less than halfway to where I should be as far as securing the identities in Azure AD. If you notice here, this is my tenant. This shows that my score is 93 compared to the industry average for the industry that I've identified this tenant to be. I'm doing better, right? So they typically are at about 43. They so 93 is much better than the industry average. And then for your typical 0 to 5 person company, 16. So significantly better than that. Now, what does Identity Secure Score give me? First of all, it shows me my score for the last however many days, right? So the last week, the last 30 days. Because there's not much change going on, this is what you see. I don't think in the last 90 days much has really changed. We'll see what it actually looks. Yeah, so it's been pretty steady the whole last 3 months. I haven't made any significant changes to my environment in the last 3 months. But what this tells me down here, what are the actions I could perform in my environment to improve the security level of my identities? And it shows me what the impact would be of each of these actions. So for example, if I forced all my admins to use MFA when they log in, that would increase my score by 25 points. So I would bump it up from 93 to whatever that is, 118, something like that. It tells me also that the user impact is going to be low and that the implementation cost is low. So let's take a look at this. If I click on the little bar, it tells me about the information or about the implementation, the improvement, what the score impact is going to be. It gives me a description of the requested action. How is it that you're going to change it? What is it you actually have to change? How is it going to affect your users, and how long it will take for the secure score update to be reflected in your secure score. I can go in here and say the status of this is I'm already doing MFA with, I might be doing RSA, right? So I can say third party, or I can say ignore. I don't really care about that. It doesn't mean that it's going to drop out of my list of recommendations. It's just not high on the priority list for right now. So the more I go through this list and implement these controls, the better my security score becomes. And we have these secure scores for Azure, for SQL, for Microsoft 365, for endpoint security, and they're really all rolling up into Microsoft Secure Score, which is shown here. So here I went to the Security Admin Center, or the Admin Portal, security.microsoft.com. And this is showing an all-up Microsoft Secure Score. So I've got the element of identity here. How am I protecting the data in my Office 365 tenant? How am I protecting my devices? Not very well in this case. The applications, and then even the infrastructure in Azure. So it's pulling all the data from those properties together into a comprehensive score. And the idea is that we don't want you to have to look at so many different portals in order to understand what your security posture is. But if I go over here and start looking at the improvement actions here, there's also a tab here that gives me more information. You'll see that the data is being pulled from different locations. So if I go to the product or the category, I can see that the category for a lot of these things is identity. But as I scroll down, if I filter actually, I can look at all the different types of categories, right? And so some of them are related to device security improvements, some to identity, some to applications, and on and on. So I can maybe assign different tasks to different groups of people in my organization. So I may have an identity group that manages identities exclusively. So I can click on this and oops. This gives me a little bit more detail that I can work with. So I can say that the action plan for implementing a user risk policy is planned, or I've accepted that risk, or I've resolved it through some other method. So this allows me to make a lot of more granular and specific things available to my security organization. So one of the things I clicked on there was the user risk policy. So if we take a look at the user risk policy, what this is doing once you turn it on and start enforcing it is it takes a look at the users, and you can specify which users. I've just decided to look at all users in this case. But it says, what is the user risk? So Microsoft, as I described before, assigns a level of user risk based on a variety of factors. Now, we are able to see billions of authentications every month against many, many properties that we manage, you know, Azure and Office 365 and Xbox and Hotmail and whatever. So we understand what is an anomaly and what is a normal login for any given user, really. And so if we see the user risk level rise medium or above, maybe we want to take an action on that. I'm going to leave it at high, right? And if I go here, what I'm saying is if any user hits a user risk level of high, then what I'm going to ask is that, once this shows up, I'm going to ask that the user be forced to change their password. This is just taking a minute to pull up. So I can force them to change their password. Or I can just block access altogether. I can just say, if their user risk level is high, just block access. And then the user calls it the help desk, you verify who they are, and you restore their access. But maybe I just want to force a password change on them. Now, so that's the user risk policy. You can turn this on for different groups. Different people might have different policies applied to them. So maybe the C-level executives have one level of policy applied to them. The finance people have another policy applied to them. The IT people have a different policy applied to them. You can do that however you want. If I go back here, and one of the things I'm going to look at is take this concept of Azure AD identity protection and look at the risky users. So I mentioned the idea of how we categorize risk. So I've got a bunch of users here that have had some sort of risk level assigned to them. Some of them have low, some of them have high, and some of the risks have been remediated for whatever reason. They were either discounted as being not really a risk, false positive, or maybe we were able to fix the problem. But let's go in here and take a look at Alan DeYoung, because his risk level is high. So if I click on him and if I pull this up, oops.
Hey, David, just to let you know, we've just got a few minutes left. We'll be wrapping up, okay?
Oh, okay. Wow.
It goes quick, doesn't it? Sorry.
Yeah. No, that's fine. So if I scroll down here, I see some basic information about Alan's account. I see that he's at risk, he's at high, and then I want to find out what exactly caused that risk. So I go to risk history. See if I can scroll this up a little bit. It's not letting me. All right. So the risk history. It shows me that at 7 o'clock in the morning on February 16th, his account logged in from a malicious IP address. So maybe this is a botnet, maybe this is, logged in from a node on the Tor network, whatever it is. That's what caused his address or his ID to be labeled as risky. So I can go in and I can say, confirm that he's been compromised. I can dismiss it. I can block him. I can force a password reset. There's a lot of different options I've got available to me. Let's see what else I can show in just another minute. Conditional access. So conditional access, we can set up policies that require users to perform a different level of authentication depending on the workload that they're accessing. So for example, what I've done here is set up a session control for Teams. So what this is saying is that for all my users who are accessing Teams, I can apply conditions depending on what the sign-in risk is, what device platform they're logging in with, and different locations that they're logging in from. If they meet this set of criteria, then I will grant them access, but maybe I require multi-factor authentication, or maybe I require them to accept the terms of use. Okay, so what actually happens in this case is I'm going to enforce conditional access application control when they try to access Teams through the browser. So let me just show you what that looks like. So I log in and I try to go to Teams in the browser. And you'll see me get prompted, right? So it tells me that my access to Teams is being monitored, and I just need to verify that that's what I want to do. So I didn't require multi-factor authentication in this case. I'm just notifying people that the access is being monitored and they can get into Teams. I didn't have time to show you Cloud App Security, but Cloud App Security is one of the most powerful tools that we have for maintaining the security of your data in a variety of locations. So for example, I'm able to see the different types of data that's being accessed, not just in Microsoft workloads. Everything just got reset here. Let me fix this. So I'm able to see the stuff that my users are connecting to these different workloads in my network. So they're getting not just the Office stuff, but they're going to Amazon, they're going to Google, they're going to Anaplan, ESPN, Dolly Drive, and I can make decisions about whether I sanction that or mark it as unsanctioned. Then one of the things I can do here is connect different applications to Cloud App Security. So in this case, I've got the ability to connect my Salesforce, my AWS instance, G Suite, Dropbox, Azure, and this way I'm monitoring the access and able to audit the access to all these properties and several others that are listed here. So you can monitor when users are connecting to their AWS machines. What are they doing? Are they shutting down machines? Are they deleting machines? You're able to track that auditing with CloudTrail. So apologize I didn't get to show you all the stuff that was in my my plan there. We ran out of time, but again, the key that we want to make sure that everybody remembers is that protecting your data requires you to protect your identities. And so where that leads us with is you have to trust no one. So thank you for your time. I appreciate you taking time to listen. That's my email address and my blog if you want to access my blog. And thank you for your time.